People in the back row, how's that for size? Is that okay? That's legible? Okay, sweet. Right, so we've defined this notion of a curve. Right, where each of x and y depends on some variable t, right? So this x depends on a parameter, this y depends on a parameter. So we can think that there's some input variable t. Often we think of this variable as representing time. That gives us an x and a y coordinate. Okay. Right, so let's parameterize something. So we've got this famous circle, the unit circle, where all of our trig happens and everything's very nice, and we want to give a parametric curve that describes that circle. So usually I start things off with drawing them, just to get a handle on what they look like. Of the thing, what would parameterize this circle? How could we get some variable t involved here? Yes, I see a hand.
Trig functions?
Trig functions, yes, okay. Which trig functions can we use to parameterize this thing? Get another hand somewhere over here, maybe. Okay, I see lots of people hiding behind the front row. The front row's got it. In the back row, middling back. Could that person with the MacBook Google the answer? Look it up. They're like, no, man, it's fine, it's okay. All right, front row.
Sine squared plus 1 squared equals 1.
Right, yeah. So, right, so you notice this, you've got some stuff that squares to 1, and you notice this kind of similarity. Okay, so there's this kind of family resemblance between cos squared plus sine squared equals 1 and x squared plus y squared is equal to 1, so there's a relationship there. And now how could we make this into a parametric curve? Yes?
xt is equals to sine t and then the y equals to
Yeah. So
X
let's,
cos and then Y sine.
yeah, so let's just pair them up, right? Okay, so. Okay, so we make this pairing. I want to point out that we could actually make lots of different pairings here, right? So I chose x to go with cos, y to go with sine, because I wrote them down in that order. But we could do alternate things. We could do other things here that would still parameterize this unit circle. Could I get an alternative way to do this? Yes. Yeah, flip them, right? Right, any other alternatives people can spot?
Add a negative in front of it.
Yeah, add a negative, sure. Okay, the point I want to make here is that there's many different ways to parameterize one curve, right? There's several alternatives, but all three of these things are valid answers. They all work, okay? Okay, so there's a parametric curve. Now, we want to look at the calculus of these things, try and figure out, tangent lines and that sort of thing. Okay, so this is sort of a standard calculus type problem. Find a tangent line to a given curve or given surface. Okay, so take, let's say, 2 minutes and just try and solve this, okay? Just go at it. If you've done the readings, it'll help a lot. If you haven't, try and create a way to do this. So ponder it for 2 minutes.